Ever wonder what's really running your car? And I'm not talking about the engine. I'm talking about the code. Today, we're going to pull back the curtain on the invisible software that, honestly, makes your car, well, a car. Get this. Your car is running on over 100 million lines of code. That is just a mind-boggling number. I mean, it's more than a fighter jet. And all of that software, written by tons of different companies, has to play nice together, perfectly, every single time. So how on earth do you keep all that from turning into total chaos? Especially when one tiny glitch could be, well, really, really bad. It all comes down to one thing, really: complexity. You see, a modern car isn't just one computer. Nope, it's more like a whole network of them, a symphony of little brains that all have to work together in perfect harmony.
Okay, so let's break this down. Your car is packed with these things called electronic control units, or ECUs for short. Just think of them as tiny, specialized computers. You've got one for the engine, right? Another for the brakes, one for the airbags, one for the infotainment screen. You can have over 100 of these little guys in just one car. But here's the real kicker. The company that built the brake computer is totally different from the company that built the engine computer, and they all have to communicate flawlessly, in real time. Because, you really don't want any lag when your brakes need to talk to your engine, right?
So, to deal with this massive challenge, the entire auto industry realized they needed some common ground, a universal language. And that solution? It's called AUTOSAR.
And this is what's so cool about the story. AUTOSAR isn't some product from one company. No way. It came from a massive partnership between companies that are normally fierce rivals. Car makers, suppliers, they all got together and said, hey, if we're going to build the safe, smart cars of the future, we can't all be off in our own little worlds building incompatible stuff. They knew they needed a standard.
So what exactly is AUTOSAR? Well, the full name is Automotive Open System Architecture, and the most important word in there is architecture. See, it's not an operating system like Windows that you just install. It's more like a blueprint. It lays down the ground rules for how all the different software pieces are supposed to be built and how they talk to each other. That way, a part from supplier A can just plug right into a car from manufacturer B. No drama. Okay, to really wrap our heads around how this blueprint works, let's use an analogy. It'll make it all click. Imagine we're building a super high-tech smart office building. Yeah, forget about code for a second. Seriously, just picture a giant smart office building. Every single office, every floor, they all need to work together flawlessly. AUTOSAR, that's the master blueprint for that entire building. All right, let's take a tour of this digital building. We're going to see how it's built, layer by layer, from the very foundation all the way to the penthouse. And each layer of our building lines up perfectly with a layer in the AUTOSAR architecture. First things first, every building needs a foundation, right? Solid ground. In our car, that foundation is the microcontroller. It's the actual physical silicon chip. It's the hardware that everything else, all that software, is built on top of. Okay, foundation's poured. Next up, the core infrastructure. This is the MCL, or Microcontroller Abstraction Layer. In our building, this is all the basic plumbing. The wiring, the HVAC, it's the standardized stuff that lets any office on any floor just plug in and get power or water, without having to worry about where it's coming from. The MCL does exactly that for the software. It lets the software run without needing to know the nitty-gritty details of the specific chip underneath. All right, now we're getting higher up. We've got the shared services for the whole building. This is the services layer. Think of it like the building's IT support, the security team at the front desk, the mailroom, all the essential services that every single tenant in the building relies on. It handles all the background stuff, like managing memory or communications. Okay, this next layer is absolutely key. How do all these different offices actually talk to each other? That's where the runtime environment, or RTE, comes in. In our building, the RTE is the communication network. It's the internal phone system, the email servers, the intercom. It lets accounting on the 5th floor seamlessly message marketing up on the 20th, and neither of them has to know or care how the wires are physically connected. The RTE does the same thing for the software, letting all the pieces talk to each other no matter where they are in the car. And finally, we've arrived at the top floor, the application layer. These are the tenants, the actual offices doing the work. In your car, this is the software that you, the driver, actually interact with. It's the code that's running your engine, controlling the AC, or keeping you in your lane. Each one is a specialist, working away in its own little office, totally dependent on all that infrastructure we just built. So, okay, we've built our fancy digital office building. But you might be wondering, why go through all this trouble? What's the point? What's the big payoff here, for us as drivers and for the car makers? Well, the benefits are actually huge. First up, and most importantly, safety. When you keep everything isolated in its own little office, it becomes way easier to test and prove that the really critical stuff, like the airbag software, is going to work, no question. Second, it fuels innovation. Car companies can spend their time dreaming up cool new features, the tenants, instead of reinventing the building from scratch every single time. And third, reusability. A fantastic piece of software for an anti-lock brake system can be used in dozens of different cars from different brands. That saves a mind-blowing amount of time and money.
So the next time you hop in your car and turn it on, just take a second to think about this incredible, invisible architecture humming away beneath the surface. This standard blueprint is what makes all the complexity and safety we just take for granted even possible. And as we barrel towards a future of self-driving cars, it really makes you think, doesn't it? How is this silent, invisible software foundation going to become maybe the single most important safety feature we have on the road?